Okay, so for this problem, we have a 3x3 grid, and one of the squares in the grid is going to be left out, and the others are going to be covered by 8 digits, 1 through 8. And we also have the condition that any two neighboring digits that are adjacent that share a side must differ by those two. It's asking me how many ways can we do this if rotations and reflections are considered differently.
Yeah. And you drew 3 different cases that are possible in terms of that square that is absent.
Right. So each of these 3 cases is different, and we can consider them separately. And at the end, we just need to multiply to account for the rotations. So either the cross-out square is in the center, it's in the middle of the side, or it's in the corner. So let's start by looking at the center. So let's think about where 1 can go, right? But for now, let's just put it like over here.
Well, I can say 1 can go anywhere because if you look there, these 8 cells form a ring, right?
Right.
So the position you choose for 1.
So there are 8 ways to choose where 1 goes.
And 1 has 2 neighbors, 2 or 3.
So let's say 1 goes there. We can always rotate it later.
And it's clearly symmetrical, right? 2, 3, or 3.
So 2 or 3, and then we multiply by 2 because of that. It can be 2, 3, or 3, 2.
Yeah.
And then the next one,
4 must be adjacent to 2.
right? Because there has to be someone else here, and it can only be 4.
I think after that it's all fixed.
Right. So this one has to be 5. This one has to be 6, and 7, and then 8. So in this case, we get 16 total ways.
Yes. Yeah.
So now let's look at the next case, where we have an x in the middle of the side. So again, it's useful to look at where 1 can go, because 1 has to be next to 2, and 3, and it cannot be next to 4, right? So that means you can only have up to 2 neighbors.
Wow.
So 1 can definitely not go in the center, right? And it can also not go over here. So it cannot go over here either, or here. So these 4 spots are the only places where 1 can go. So these 2 are symmetric. We can just flip, and these 2 are also symmetric. So that means we only need to look at 2 particular cases. If 1 is here and if 1 is here. So let's get this one first. So this guy can be a 2 or a 3, right? So let's try making it 2 first. And then, so this is 2, right? These 2 have to be 3 and 4.
Yeah, because only 2 neighbors, 2 can have.
Right, because 2 cannot be next to 5. So it can be 3 and 4 or the other way. Now the rest will fill in quickly because 5 has to go here, right? And then if we look at 6, 7, and 8, where can they go? Well, we can put
6 out is beside 4.
right. So 6 has to go here, and then this cannot be 8 since it's a 5.
Yeah.
So this 5 is 7, this is 5 8. Right. Okay, so that's one way.
And what
Now,
if you flip
We
4?
flip the 3 and 4. So now, if we flip the 3 and the 4, or we put a 4 here and a 3 there, so the 5 still has to go here.
Yes.
Right.
But 6 3 can have another neighbor.
Right. So now we're stuck with 3. So this case is invalid. Okay. So now we've exhausted the 1 here, 2 here. The next case is 1 here and 3 here. So over here, if we look where the 2 can go, can't go over here because there are too many neighbors. The only other guy 2 can be next to is 4. So 2 needs to be tucked into the corner and 4 goes there.
Yeah.
Then 5 has to go here. And again, we have 6, 7, and 8. 4 cannot be next to 7 or 8. It can only be next to the 6. And then these 2 are, of course, as well.
So you found the second configuration.
So with 1 here, now we found 2 configurations so far, right? And there are no other ways with 1 in that position. Okay, so now let's talk about what happens if 1 goes in this corner.
2 and 3 are neighbors.
right? So again, there are two ways of them. Let's try this one first. So,
4 must be.
Usually trouble here, I think.
right, because 2 has 2 neighbors now, and he's stuck. If we try to swap them,
6 happens.
same thing because the 2 is stuck.
Mhm.
So that means that 1 cannot be in the bottom corner. So 1 is either here or here, which means we need to double this. And then the next thing we have to account for is the ways to rotate this, right? Because the x can be in any one of these 4 positions. So we need to multiply this by 8.
By
Or sorry, by 4. And that gives us 2 times 2 times 4, which is 16. So 16 here, 16 here. Let's see what happens in this last case. Okay, so we can try starting in the same way. Where can 1 go? Can't go in the center, and it can't go to either of these 2 spots because it can only have 2 neighbors. So let's try putting it in one of the corners. Or it can also be up next to the x. So if the 1 goes here, then these 2 have to be 2 and 3 in some order, right?
2 has to go to the corner.
2 has to go to the corner and 3 goes there. But we immediately run into troubles because 3 cannot be adjacent to that many people, right? If you try to fill this in, you get 4, and then where can 5 go? Well, 5 and 6 are the smallest ones we can put in here, but 6 is already too big to be next to 3, right? So this case is bad. So just to recap, so far we've proven 1 cannot go here, cannot go here by the same logic, and it cannot go here because there are too many neighbors, same with these 2. So we just need to try this one and this one. This one's symmetric. So let's try putting a 1 here. Well, now 2 and 3 have to go here and here. We don't want the 2 to be there because then we cannot find 2 neighbors for it. So 2 has to go here and 3 has to go here. So now the next number is 4. It's got to go next to the 2. And 5 has to go next to the 3. And now we need to fit in 6, 7, and 8. But the problem is 4 cannot be next to 2 of those 3, right? The only neighbor it can have is 6. So it has too many neighbors in this case as well. So that means that 1 cannot be in this square, cannot be in this square either. The only possibility left is if 1 goes here.
If you can eliminate it, you think about 8.
Right. Because 8 is symmetric to 1, right?
8 has to also go there.
So 8 has to be in one of these other squares, but all of them are bad. Because if we consider taking every element and then flipping it so 1 goes to 8, 2 goes to 7, etc., we're going to get another bad scenario. So it means this entire case is impossible. And there are 0 ways. So we've looked through every single case now, and if we add up our numbers, we get 16 plus 16 plus 0, which gives us a final answer of 32.